Okay, so last we were talking about stoichiometry. So this is just wrapping it all up. Now, stoichiometry is like the bread and butter of chemistry. Okay, so we've already kind of talked about how to go from moles of one thing to moles of the other thing that's in a chemical equation. So the key is always to balance, make sure you have a balanced, correct chemical equation. That is the number one thing. The next thing is to remember that we're going from moles of one thing to the other. And so we want to use dimensional analysis to sit there and make our way through that process. Okay? So now when we're starting off with mass, we're going to be given a mass. That's going to be our given mass. We're going to go from our given mass, we need to change that to moles, right? And so we're going to use the molar mass of the given to sit there and determine the number of moles. And then we're going to use that mole to mole ratio from the chemical equation. And then we're going to use the molar mass of what we want to determine the mass of our final product. Okay, so this is just like a quick schematic of everything. It kind of gives an idea of what we can do with doing these conversions, and also what we're going to need to sit there and do it. So if we have the reactants, so we could basically, if we're given our reactants and mass, we're going to use molar mass to determine the number of moles. And then if we're given, can you guys see the screen? Thumbs up if you guys can see the screen.
Yes.
Yes.
So we're going to use molar mass to get the number of moles. Now, from the number of moles, we can figure out the number. You use Avogadro's number to figure out the quantity, the number of molecules, or the number of atoms that are going to be produced by that particular thing of our reactant. We're going to use the balance equation to sit there and get us to the moles of the product. Okay. So let me show you what I mean by that. How many milligrams of nickel 2 chloride are in a solution if 503 milligrams of silver chloride is precipitated in a reaction of silver nitrate and nickel 2 chloride? So what is the first thing that I want to do? You guys can answer. Somebody
Write down your given.
Very first thing I want to do. Write down our given. That's what somebody says. Okay, so we want to write down our given. Okay. That is a very important thing. And normally that would be the first thing that we're going to do, right? So here's our given. We have 503 milligrams of silver chloride. Now, this isn't going to make any sense to us if we don't have a chemical reaction. So what is the first thing that I should do naturally in this case? Justin, what do you think the first thing that I'm going to do?
What? Can you repeat that again?
Okay, so you're telling me that I need to write down the chemical equation, right? So that's what the first thing that I want to do. I want to write down the chemical equation. So this problem says, how many milligrams of nickel 2 chloride are in a solution if 503 milligrams of silver chloride is precipitated in a reaction of silver nitrate and nickel 2 chloride? So what are my reactants in this case?
Nickel 2.
Okay, so what does silver nitrate look like?
Would be 503 mg.
Silver nitrate. Anybody want to help me out here?
Silver nitrate is AgNO3.
That's right. Okay, so silver nitrate would be silver Ag and nitrate
NO3.
your polyatomic ion tables. Okay, nitrate. Anyone?
Ni.
NO3. Okay, and we know that silver, when it just says silver, it's always going to be silver 1, right? So AgNO3 would be silver nitrate. And it's a solution, so is that solid, liquid, gas, or aqueous?
Liquid?
Q.
Oh, aqueous. Aqueous.
And nickel 2 chloride? Nickel? Ni, okay. Nickel 2 chloride, so that means it's gonna have 2
NiCl.
chlorides. That's right. And it's a solution as well. So that means it's gonna be,
Aqueous.
okay, and our products. Ag, silver is a +1 charge. Chlorine is a -1 charge, so it's Cl. Yeah, Cl.
S. Silver.
Okay, and this says it's a precipitant, right? So it says precipitates. What does that mean? Solid, liquid, or gas?
Solid.
Solid.
Solid. So anytime that you see the word precipitant, it means solid. Or a precipitate, it's a solid. Okay, and what is going to be the other product? But what should be first? It should be nickel, right? It's the metal first. Running out of room here. And let me drag this over. And it's nickel 2, and the charge on nitrate,
3.
what is the charge on nitrate? What is the charge on the nickel? That's right, it's a negative. The nitrate is a negative. That is correct. So how many of them are going to need to balance out nickel 2? That's right, it's going to take 2, right, to balance out that nickel 2. So if I have a +2 charge, I'm going to need 2 of those negatives to sit there and balance it out. Okay, so okay, so is it balanced? No. What do I need to do to balance it?
DJ, what's up? What? No,
So we have Ag. How many Ags do I have?
it's
on
not
each side?
candy.
1 on each side. Cls. How many do I have on each side? Okay, so what do I need to do so that would be balanced? Put a 2. So then that also means that I have to change this to a 2, right? That's right. Yep, and then now everything is balanced, right? So now that's 2, that's 2, it's 2, and then our NO3, we have 2 on both sides. And then we have 1 nickel on both sides, 1 Ni. So now it's balanced, right? Okay, so now that we have a balanced equation, we can actually use this to sit there and determine, we can use our given, you know? So our given, Alyssa's told me that it was the 503. Milligrams of silver chloride, AgCl. Okay, so I have 503 milligrams of silver chloride. Now I want to get to what? How many milligrams of nickel chloride? That's what I'm looking for, right? So how am I going to go from silver chloride to nickel chloride? The first thing that I want to do, since this is mass, I want to change it to what? Moles. That is correct, Alyssa. We want to change it to moles. Okay, so how would I change this to mole? I would basically use the molar mass.
Sit down.
Now I'm going to tell you a little secret
Sit
here.
down.
So if I have grams per mole, so what is the molar mass of silver chloride? Anybody know? Let me pull up it's atomic mass. That's right. So it will be the atomic mass of silver chloride, right? So what is the atomic mass of silver chloride? Yep, silver and chloride put together. That's right. Oops. Silver is going to be 108. Okay, so Ag. So 108, and you said 35. So isn't it 35.45? Is that right? Yeah. And then that's, yeah. So let's go ahead and put the 107. 107 point, is it 87? So then, so we'll say 107.87. Okay, for Ag, there's Cl, so then that's 2, 3, that's 3, 3, 1. Oops, sorry, 4, 1. So 143.33. Okay, so now this here is grams per mole, and we have milligrams. So if it's 143.33, if I do a conversion to change this to grams per mole, or let's say milligrams per millimole, so how many milligrams will equal a millimole? I mean, let me say that differently. How many milligrams will equal a gram? Mil.
1,000.
How many milligrams will equal a gram? What does mil mean in Spanish?
1,000.
1,000. So if I have a 1,000 milligrams equals 1 gram. So then how many millimoles will equal a mole? Mil means what? The atomic mass is in grams per mole. Okay, but how many milligrams will equal a millimole? I mean, how many millimoles will equal a mole? Mil, 1,000, right? So 1,000 millimoles, millimole equals 1 mole. Okay, so if we did that crossing out, that's going to cross out, moles are going to cross out, grams are going to cross out, and then 1,000 is going to cross out. So I'll end up with the same number, right? So anytime that I'm going from like a millimole, or say grams per mole, to a milligram per millimole, it's going to be the same number. If I go to picograms per picomole, it's going to be the same number. That ratio is always going to be the same because you mil over mil, right? Or pica over pica, or gram over mole. So it's going to be that same number. So in this case, we're going to use that 143. So 143.32 milligrams per 1 millimole. Okay. What is so embarrassing? Did I forget something?
Oh, I'm sorry. It's because my mic, I didn't know my mic was on and my kid was crying and I was like yelling at my kid, but yeah. Anyways.
Okay, so, and that's AgCl. Okay, so now I want moles of nickel 2 chloride. So how do I get to moles of nickel 2 chloride? Are you there? Anyone? I should say not moles, millimoles of nickel 2 chloride.
Mole of AgCl in the bottom.
Why do I have this chemical equation? What is the purpose of it? Yeah, we want millimoles of nickel 2 chloride. So what is the ratio of silver chloride to nickel 2 chloride? We're going to use the chemical equation. So I have millimoles. So then that'll be 2 millimoles of AgCl. And that's going to be 1 millimole of nickel 2 chloride. Okay. So I'm going to continue down the next line here. Okay, but I want milligrams of nickel 2 chloride. So how do I go from moles? Because if we look at our units, what we have left, let's see. Millimoles of silver chloride are canceled out. I'm sorry, milligrams of silver 2 chloride is canceled out. Millimoles of silver chloride is canceled out. So how do I get from moles to milligrams? Millimoles to milligrams. How did I do it over here? What is this? What is this up here? So we calculate the molar mass, okay? So how do we calculate the molar mass of nickel 2 chloride? Okay, so what is the mass of nickel? Let's see, you said 58.693. Let's see, nickel. So 58.693 for nickel. And we have how many chlorines? The 2 chlorines. Times 2. That's going to equal 70.9. We add that together. So what is that? 9, 3. Okay, so down here we're going to have moles are on top, so we want millimoles are on top, so we want 1 millimole at the bottom. Yeah. Okay, so then millimoles are going to cancel out. Millimoles are going to cancel out, and we're going to be left with just milligrams. That should be. How many sig figs should I have?
3.
3.
We're going to have 3. Okay. Questions, concerns? Cash?
So far, no.
Cookies?
Cookie.
Pretty simple, right?
Yeah.
So you got to remember that you're going to be using your chemical equation, right? Chemical equation allows you to get that mole to mole ratio. That's located right here, that middle part. Okay. This here is your molar mass. Molar mass. And then this is also your molar mass. Okay, so can you guys see that, how it works out? Yes, we will be going over percent yield. And divided by 2. Yeah, so this, all the stuff on top is multiplied together, so you multiply that, and then you divide it by these. Yeah, you can multiply, yeah, these together and then divide that, yes. Yeah. Okay. Okay. Next thing is percent yield. Did I tell you my percent yield story? I did tell you guys my percent yield story, right? Did I tell you about, I almost dropped out of college? Okay. Percent yield. Okay. You don't remember that? I'm pretty sure I told you guys that story. So let me clear the screen. And then I'll tell you my quick story, real quick. Okay, so I was taking an analytical chemistry class. Okay, that's fine. I was taking an analytical chemistry class. And during my analytical chemistry class, I kept getting, so analytical chemistry is basically you calculate a lot of percent yield. The goal is to try to get as close to the number that you're supposed to get. You're trying to get 100% recovery of whatever chemical that you're trying to produce. And, or at least that was my thinking of it. So when I actually took analytical chemistry, you're using all these different devices to sit there and measure the purity of certain things and all of that. And again, you want to try to get as close to the pure as possible as you can get. And so we did the experiment, and I'm, you know, I think I'm pretty smart, right? And so, and I'm ahead in chemistry, and I'm ahead in this, and so I'm like, this is my wheelhouse. I can do this. So I go in the chemistry lab and I do the experiment. I'm just going, bam, get it done. I calculate my percent yield. I get 86% yield. Now I should probably tell you what percent yield is, so it'll make a little more sense. Okay, so percent yield is the actual yield over theoretical, or what we call ideal. Ideal is what you're going to calculate. Your actual is what you actually get, what you collected, what you actually did with the experiment, right? Theoretical is what you're calculating on a piece of paper. So like what we did in the last example, that would be my theoretical yield or my ideal yield. That's what I should get if everything worked out perfectly, okay? So percent yield is your actual over your ideal. Now, if you get perfect, you'll have your actual and your ideal will be exactly the same. If it isn't perfect, then you're going to end up with less. Does that make sense? Okay. So I got 86% yield the first time I did the experiment. So then I'm like, okay, I got 86% yield. That's not good enough. I want to get 100% yield because I'm a bit of a perfectionist. 86% is not enough. So let me try again. So I do it again. Damn, and I whip it out. I do it fast. And, you know, I'm pretty good. I've got my stuff kind of coordinated. I have the little system going. I whip it out. I get 87.5%. Okay, so at this point, this is the third time I repeated the experiment. I'm getting a little peeved and I'm like, maybe I'm just going too fast. So if I go a little bit slower, I'll be able to get this. So I did it again. .9% yield. Okay, at this point, I'm a little upset. I'm hungry. Is that hangry? Is that I'm hungry, I'm mad, I'm a little, so I'm like, okay, let me go eat something and then I'll come back and do the lab again. So I talked to the TA and I'm like, hey, I did something wrong. It's not working out. Is there any way that I could come back to your lab later tonight? My friend was in that lab anyway, so I'll just go, if it's okay with you, if it's okay if I can come. He's like, yeah, sure, come back. Mr. Henry, come back, that's fine. So I go and I eat, and I'm like, okay, and I think about it, and I write everything down. I put a little checklist to make sure that I'm not making any mistakes and everything like that. I look over it again, make sure that I did everything that I was gonna do. So I write out my procedures, step by step, check box, everything. So I get back into the lab. I'm going. Oh, wait. There's one thing I forgot to add. So I talked to the guy that was sitting next. And this guy is like, how do I put this the nicest way? So those people that you're like, they're really nice people, but they're dumb as a box of rocks? You guys don't know anybody like that? And, and
they call the
they're
village
really not
idiot?
here to get a degree. They're just kind of here to just, because daddy and mommy want them to be, right? Not the smartest guy in the room, right? So I'm thinking to this, I ask him, I'm like, hey, what did you get for your percent yield? And he's like, dude, I got 100%, right? So I'm thinking to myself, if this idiot can get 100%, I should definitely be able to get 100%. So let me make sure I do this right, because I know that he is a big idiot. Right? So I do it again. I get 86% yield again. Now, at this point, I've done it 1, 2, 3, 4 times. I'm like, this is the 5th and final time. If I do not get this, and this is what I said in my head, if I do not get this, maybe I need to quit now, save myself all the pain. So I do it one more time. I get 86% yield again. 5th time, I am pissed. I had a quick temper. You guys have gotten a nice me. You haven't got the really mean me that yells and screams and cuss all the time. That's me when I was younger, right? So I'm mad. I take my lab notebook, I throw it across the room into the garbage can, and then I just leave the room and I kick the garbage can as I'm leaving, and I'm just cussing. Damn, son of a bitch, blah, 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 right? I decided I'm done quitting, right? I'm like, I can't get this damn thing right. And the idiot, the village idiot can get it, but I can't get it, right? So I'm like, I'm done. So I'm walking out of the classroom and everything like that. And I'm walking down the hall. And the TA comes out. Mr. Henry, get your butt over here. What's going on? Why did you, and he picked up my lab notebook and hands me my lab notebook. Why did you throw this in the garbage can? What's going on with you? I'm like, I did the experiment. I've done it 5 times. Every time I got around 86%. And he's like, uh-huh. And I'm like, and what? It should be 100%. And he's like, okay, Mr. Do you understand what you're doing? And I'm like, yeah, I'm supposed to recover this chemical and I should get 100% back. And he's like, okay, let me show you something. So he takes me in the back room where they have all the chemicals stored and everything like that. He shows me the bottle. And on the bottle, it says, the chemical that we were using, it says 86% purity on it. So in other words, regardless of how much I did it, I was going to end up with 80%, because 86%, because it was 86% pure, the chemical that we were actually working with. So the moral of the story, there's a couple of things about this, right? The first thing was, because I was really going to quit that day. I was upset, kind of crying inside, cussing, Even if things fail, don't give up, right? That's the first thing. The second thing is, don't listen to the village idiot, because he is the village idiot, okay? So you want to make sure that you're getting your information from a reputable source. And then you want to verify even that reputable source. Okay. And the third thing is percent yield. Every experiment that you're ever going to do, you will never get 100% because everything has some impurities. You're going to have incomplete reactions. You're going to have side reactions. And then sometimes you're going to get a little extra added in because that sweat that Alicio puts in there as he's working on the thing as well. So don't base your whole decision and your life career on a bad experiment. Okay? Are you guys with me? Good. Okay, so now that I told you that, percent yield is actual yield over theoretical, or actual yield over ideal, okay? And you multiply by. So we're gonna go through this whole process again, where we're doing stoichiometry. We're gonna get an actual value. So here's the question for you. A solution containing 3.18 grams of barium chloride is added to a second solution containing excess sodium sulfate. Barium sulfate precipitates. Calculate the ideal yield of barium sulfate. If the actual yield is 3.37 grams, calculate the percent. Okay, so what is the very first thing that I want to do? What did we do last time? First thing. Okay, got to identify our givens. Okay, that's fair. We can identify our givens. Yes, and then we need a chemical reaction. Okay, so what is our chemical reaction? What are our reactants? Barium chloride. So chemical formula for barium chloride? BaCl. Barium has what charge associated with it? Is it just one positive? It's two positive because it's in the second group 2. So we need 2 chlorines to balance it out. And it's a solution, so it's AQ. And then our other reactant. So sodium sulfate, chemical formula for sodium sulfate. Okay, so we need those 2 sodiums to balance it out. All right. And it's aqueous, that's correct. You know, it's so weird not having to yell at somebody, calm down. Are you guys listening? Okay, and then our product, BaSO4. And it says precipitant. What does that mean again? Solid, that's right. Precipitant, there we go. And then our other product?
Sodium
Okay, but it
sulfite.
would be Na2. Would it just be Na? Because what is the charge on sodium? Sodium.
Positive.
Sodium is positive and Cl is negative, -1. So they have to balance each other out. So you just don't, so when you do that mixing, you don't just assume that it has the same subscript. You have to balance it out with who it's with. Okay, so you only need one of each. Okay. Okay, is this, and it's going to be aqueous because we know that sodium chloride is aqueous. Okay, is it balanced? Is the chemical equation balanced? So it's not a balanced equation. So what do I need to do to balance it?
Write out your constants.
How many sodiums do we have over here? On the
Two.
reactant side? 2. And on the product side?
Yeah. 1.
Okay, so what do I need to do to make it 2?
You put a 2 in
I
front of
need to put
the
a 2 in front
Na.
here. Okay, how many chlorines do I have?
Chlorines. You have 1. No, 2 actually.
On both sides?
Yes.
Yeah, we have 2. Yep. We just put the 2 up there, right? Okay, so now we have a balanced chemical equation. Is that correct?
Yeah.
Good. Okay. So now that we have a balanced chemical equation, I can use my given. So I have 318 grams of barium chloride. Sorry, 3.818 grams of barium chloride. Okay. So what am I going to want to do with this? I'm given mass. I need to change it into what? So that I can use my chemical equation. I need to change it into moles. That is correct. So if I need to change it to moles, how do I change it into moles? Okay, so I need to find the molar mass. Okay, what is the molar mass of barium? 137.33. Okay, and chlorine? Chlorine, not fluorine. Chlorine. So 35.45 times 2, since there's 2 of them. So that's going to be 70.9. We add those together. So that's 208.23. And that's grams per mole. That's right, because it gives me grams per mole. And then so grams are going to cancel out, and then we're left with just moles. Oh, well, they are different. Molar mass is grams per mole. Yeah, that's right. Yeah. That's barium chloride. Okay, what are we trying to find? So we want barium sulfate. So we want the ratio between barium chloride and barium sulfate. Where am I going to find that at? What is the mole to mole ratio? Here's barium sulfate. What's in front of it? 1 and 1. So it's a 1-to-1 ratio. So 1 mole of barium sulfate over 1 mole of barium chloride. Okay. A little more room. Okay, so then that would give me moles of barium sulfate. So how would I get to grams of barium sulfate? The molar mass, that is correct. So you're going to use that molar mass again. So we have to calculate the molar mass of barium sulfate. Okay, so we know that barium was 137.33. So sulfur is how much? Yep. So sulfur is 32.06. So we said barium is 137.33. And we have oxygen. How many oxygens do I have? So let's just say 16. So 4 times 16. Yeah. Okay. Okay. So we have 4 plus 37 plus 137.33. So we end up with, in this case, it's 238. I mean, sorry. Yeah, 238. Okay, 0.39. Okay, so 238.39. Okay, so then we have 1 mole of barium sulfate equals 238.39 grams. Of barium okay, so these are going to cancel out. It's going to be what? 317? 3.64. Grams of barium sulfate. Okay, so if our actual yield was 3.37, how do we calculate our percent yield?
You divide them and multiply by 100.
What is percent yield again? What is percent yield again? It's actual over theoretical, or actual over ideal. So we get times 100, right? So we have 3.37 over 3.64 times 100 equals 92 point. So 3 sig figs 92.6%. Okay, so we have a 92.6% yield. Okay, questions, concerns? Kool-Aid. Okay, so when we did the calculations, so when we did those calculations, we had the molar mass. First off, we went from the 3.18
Mhm.
grams, and that was the barium chloride, right?
Yes.
Okay, then we used the molar mass of barium chloride,
Right.
and I can't remember that. That was like 2.
It was
30
208.223
Okay, 2.8
grams.
grams per 1 mole.
Yeah.
So that's the molar mass. Then we
Right.
went, and that's all of barium chloride. Okay, so we used the chemical equation, which we had, I'll write it up here, our barium chloride plus
Sodium sulfate.
Yep. Our sodium sulfate yields
Get out of there, please. Thank you.
our barium sulfate
Yeah, the sodium chloride.
Yep. and our sodium chloride. And we know this is AQ.
Oh yeah, and then the coefficient is here too.
That's right, and there's a 2 in front of there, and everything else is 1. Yep.
Right.
Yep, these are AQ. Okay, so since we had a 1-to-1 ratio, 1 barium chloride to 1 barium sulfate, that allows me to get the amount of barium sulfate I can make in terms of moles. I was wondering why it was so quiet. Okay, and then we calculated the molar mass of barium sulfate. So that's 1 mole was equal to 238.
Yeah, 0.39 grams.
Yep. Okay, so then that gives us our barium sulfate. Now this here is going to be our ideal number, right?
Okay.
So that's going to equal our ideal barium sulfate, which was 3.64 grams. So ideally, based upon our calculation on the piece of paper, that's what we're going to get, right? So percent yield is equal to actual over ideal times 100. The problem gives us our actual yield. So then we just plug that in, 3.37 over 3.64 times 100. And that equals 92.8, is that right?
That's the basic.
Percent, that's right. Okay, does that make sense?
Yeah, now it does. I don't know why the first time it kind of like, I don't know. I just had to see it again, I guess. But yeah,
Yeah.
it all makes sense now.
Yeah, there's
Yeah, me
numbers
too. It makes
everywhere
sense as
too.
well.
What was that?
It also makes sense as well to me as well.
That's good. That's good. And I was wondering why it was so quiet. Okay, so let's keep moving forward. Okay. Okay. Let's go clear. Okay, so what are we going to do here? Oh, it paused. Hold on. So we're going to find our givens, right? So who are our givens? 95% yield. Okay. So let's read
1.50
the whole
grams.
column. What was that? And the 1.5 grams.
Yeah,
Of
1.5
what?
grams. Sodium nitrate.
Okay, of sodium nitrate. Okay, so it says solid sodium nitrate decomposes to solid sodium nitrite and oxygen gas upon heating. One set of reaction conditions gives 95% yield. What is the mass of sodium nitrate that will be produced by decomposition of 1.5 grams of sodium nitrate? So what is the first thing that I'm going to do then? Now that I've already identified what's given. First thing. What did we do in the last question? What do you mean by we just put everything together? We put our chemical reaction. So what is our chemical reaction here? So what does sodium nitrate look like? Chemical formula for sodium nitrate. Group 1 metal. Group 1 metal. Group 1 metal. Group 1. Na, okay. And nitrate? No, we know that Ni is nickel. Nitrate, NO3, that's right. Okay, we know that this is a solid because they told us. So what are our products? It says it decomposes. So we have this guy decomposing. Okay, so what does solid sodium nitrite look like? Okay. NO2, that is correct. That's right. 8, you lose 1, it's ite. If you lose another one, it's hypo. Oh, sorry. Thank you. 2. And it's a solid. And we're also making, what else are we making? And what is oxygen gas? What is the chemical formula for oxygen gas? Are you sure? Oxygen gas. Have no fear of ice cold beer.
O2.
O2. Okay, is it balanced? No, what do I need to do to balance it? You said a 2, and then there's a 2 here. Okay, and then is it balanced? write it down, Na. So I have 2 here. I have 2. N's, I have 2 and 2. And then O's, I have 2 times 3 is 6. And then 2, that's 4 plus 2. So that's okay. So now we have a balanced equation. Okay, so now that our equation is balanced, we're going to use our givens, right? So we have 1.5 grams. So 1.5 grams, 1.50 grams. And that's sodium nitrate. And we want to get to sodium nitrite. Oh, so you said molar mass, that's right. So we need to get to the molar mass. That is correct. So you said for sodium, so let's say 23. So Na is 23. Okay, nitrogen is what? So 14. And oxygen, so 16, and there's how many? There's 3. So 3 times 16. Okay, we add them all together. So that's what, 60, 71, 85. So we have 85 grams per mole. Okay, so we have 85 grams per mole. So we're going to use that. So am I going to put 85 on the bottom, or I'm going to put it on the top? On the bottom. Because I want the grams to cancel out. So that 85 grams and 1 mole on top. And that is sodium nitrate. Okay, so how do I get to nitrite? Yeah, we do, but there's one step before that. Although it doesn't make too much of a difference here, but in other cases it may. Got to use the chemical equation for something. What is the ratio of nitrate to nitrite? Are you sure? What is that ratio? It's 2 and 2.
2.
Yeah. So 2 moles of nitrate and then on top 2 moles of nitrite. And now we need the molar mass. So we could probably just subtract this 16 from here. Would that be the same? You mind if I put it on the other line? Down here. So for every, we have N2, so 1 mole of NaNO3, I mean NO2, that's going to equal, well, if it's 85, 85 minus 16 would be 69. Is that right?
Yes.
Okay. So what do you guys get? How many sig figs? Yep. Grams of sodium nitrate, or sorry, nitrite. Okay, so this is my theoretical, right? Or ideal. And it tells me, it says, I have 85% yield. I mean, sorry, not 85, 95% yield. So that's 95% is equal to my actual, which is what I don't have, over my ideal, which is 1.22. Yeah, times 100. So yes, we have to change it. So we get 95, so that's 0.95 times 1.22. Yeah, because this here, well, so our actual is going to be it's going to be 1.15 or 16. 16 grams. Okay, does that make sense? Those at home, oh, there's a message. Okay. Yeah, I'm a little slow at getting all the messages. Sorry about that. Can you guys hear me?
Yes.
Okay, good. And I can hear you
Yes.
too. So are there any questions? Okay, excellent. I like it when there's no questions. Okay. Okay, so the next thing I want to talk to you guys about is limiting reagents. Do you guys like cheese sandwiches? Cheese sandwiches, grilled cheese sandwiches. Grilled cheese sandwiches.
Yes.
Okay, so I love grilled
No.
cheese sandwiches. Okay. So now I want you guys, now seriously, this is really important for you guys to understand this. Really, really important. Now, when you make a grilled cheese sandwich, right, you have 2 pieces of bread, right? So we're gonna say 2B, 2 pieces of bread plus 1 slice of cheese. And that's gonna equal 1 sandwich. Okay? You guys got that? Okay, now you guys agreed to that, right? Okay, good. So if I have 15 slices of bread, 15 breads, and I have 5 cheeses, how many sandwiches can I make? I said, if I have 15 slices of bread and I have 5 cheeses, how many sandwiches can I make? I can make 5 sandwiches, right? So now, which is in excess, bread or cheeses? Bread. Okay, so now that's limiting reagents, right? So limiting reagents is just determining which reagent is limiting, right? That basically will dictate how much of whatever you can make, okay? So if you only have 5 cheeses, you can only make 5 sandwiches, right? Even though you have 15 slices of bread, right? So the bread is in excess. Do you guys understand that? Okay, good. I love it when nobody answers. Okay, so this is another example. So here we have 3 carbons and we have 2 oxygen gases, or oxygen molecules. So if we're making carbon dioxide, how many carbon dioxides can we make? That's right. So for every 1 carbon, it takes 2 oxygens. O2 is O2, right? So CO2. So I only have 2 oxygen molecules. So I can only make 2 carbon dioxides. So what is in excess? Carbon is in excess. You guys get that? Great. Okay. So let's see if we can use it. So going to go through this. This will probably be the last slide that we'll get the chance to go over. Okay, so it says calculate the mass of antimony 3 iodide, SBI3, that can be produced by the reaction of 129 grams of antimony. SB, it has an atomic number of 51, and 381 grams of iodide. Okay, so anytime, here's the rule of thumb, anytime that you see both of your reactants having values in terms of grams or moles or whatever, and have some number associated with both of them, that's going to tell you that you're probably working on a limiting reactant problem, right? So first thing that we're going to do is do what? Underline our givens. Okay, so what is the chemical reaction? Plus, what is the chemical formula for iodide?
I2.
I2, that's right, because we know that iodine is a diatomic, and that's going to yield SBI3. Is it balanced? No. What do I need to do to balance it? Okay. Okay. Piece of cake? Okay. Okay, so we have a balanced chemical equation. So, and we are given 2 values to start off with. We have 129 grams of SB, and we have 381 grams of I2. Okay, so we need to be able to compare apples to apples, right? So what I mean by that is we want to look at how much, in this case, antimony that we actually have and how much we're going to need if we use the iodine. Okay, so we want to put it in terms of antimony. So what is the molar mass of antimony? SB.
One 29. Oh, wait.
Antimony is 129. 128.
122.
122. Well, I'm getting numbers everywhere. So 122 grams of SB per 1 mole. Is that correct? Okay. So this would give me the number of moles of antimony, right? And we want to compare moles to moles, right? Because that's how we do it, right? It's quantity that we're going to be comparing, moles to moles. So 129 divided by 122. Okay. And that's moles of SB. Now, iodine, oops. Hold on. Fix this. Okay. Man, this thing is acting crazy. Okay, so it's 127, but there's 2 of them. Times 2, right? So 127 times 2 is 254. Grams per 1 mole. Okay, now I said I want to compare apples to apples. In other words, I want to make sure that I'm comparing the antimony that I actually have to the antimony that I would need if I use the iodine. Okay, so what is the mole to mole ratio of SB to iodine? 2 to 3. That's right. So for every 3 iodine, I have I have 2 SB, 2 moles of SB. Okay, and that's going to give me my moles. Okay, so if we do that math, so it's 381 divided by 254 times 2 divided by 3. There we go. So it should be 1 mole of SB. Okay, so this is the antimony that we actually have. This is what we would need to react with this many grams of, okay? So which one is limiting and which one is in excess? This is what we actually have. The top one is in excess because we have 1.06 moles of antimony. And if we started with the grams of iodine, we were only going to need to use 1 mole. So you're right. The top one is in excess. So antimony is in excess. The iodine is limiting. This guy is limiting. Okay, so that means that the limiting is going to dictate how much we have. So we have 1 mole of antimony actually. So we can use that 1 mole of antimony. So I'm going to put that up here, 1 mole of SB. And they want us to calculate how much antimony 3 iodine we're going to be producing. So if we have 1 mole of antimony, that's how much we're going to be able to make. So what is the molar ratio between antimony and antimony 3 iodide? It's a, what is it? 2 to 2. So it's a 2 to 2 ratio. Okay, the molar mass of antimony antimony 3 iodide. So 122 plus 127 times 3. So 1 mole SbI3 is 503 grams. So 503 because we have 1 divided or times 2 divided by 2. So the answer is just going to be 503. And that's a SbI3. I'm running out of room. So SbI3. Okay, so that's my answer. So the second part is, it says, so also find the mass in grams of the element that would be left. Okay, so if we know the conservation of mass, what we put in, we have to get out, right? So if we put all of this in there, we could do it a couple of ways. We could add all of these together. So that's 129 grams plus 381 grams, and then minus, because this is how much we actually produced of our product, and then that would tell me how much would be in excess, minus 503 grams. So based upon law of conservation, what you put in, you got to get out. So whatever you don't make, what did you guys get? 7? And that would be of I2. Because that was in excess. Oops. Okay, piece of cake. Okay, questions, concerns, Cash, Kool-Aid. Okay. There's one last thing that I wanted to go over. Okay. Actually, I guess that's going to be it. So we went over limiting reagents. Okay. So gonna wish you guys the best of luck on the exams. You know, you guys should do okay. And hopefully I don't see you in CHEM-002A again. If anything, I'll see you in CHEM-001A. Okay. So are there any questions?
Yeah, Dr. Henry had a one or two questions, I guess, really quick.
Okay.
When you're doing stoichiometry, like the steps that we were just doing, how do you know, I guess, how many significant figures the answer should have when you have all of those calculations there?
Yes, that is a good question. So typically it's what's given. So your givens are going to typically dictate how many sig figs you have. Okay. So if you're given 3 sig figs initially, then your answer should have 3 sig figs, because the molar mass is basically going to be used like an estimate, right? Because depending on the periodic table that you have, it's always going to be an estimate. So you're never going to be 100% sure about the number of sig figs with that. So you never want to use that as your sig figs. You're only going to be using what's given to you.
Okay.
Okay. Does that help?
Yeah. And then, my last question here, it's a nomenclature question, but I just haven't been able to kind of figure it out really well on
Okay.
my own. So I'm gonna type in the compound on the chat.
Okay.
So 2 is
No. I know it keeps popping up.
it was just a little confusing because
Yeah.
SCO4 is not one of the polyatomic.
Yes. So this guy would be called, I'm going to put it on the whiteboard. Oops. Okay, so it's Al2, SeO4, and there's 3 of them. Is that correct?
It's SeO2 2. Did I type it out wrong? Let's see.
SeO2.
Oh yeah, I typed it out wrong.
Okay.
Let me rewrite it really quick.
Okay. Okay, so you have Al2, SeO2. Oh, that's interesting. And are you sure that there's 2 of them? Bye.
Yeah, I'm looking at it right now.
For the labs, you do the lab report of how to do the lab report. That was handed out to you. I'll send you an email with it as well. Yeah, so no, actually it was handed out to you guys. The procedures, how to do it. Yeah. So are you, I'm saying, are you sure about this guy? Because it doesn't seem to be correct.
Yeah, it was, well,
This should be a 3.
I don't know if you could answer, because it's one of the questions on the exam too. I'm doing test corrections and I just wasn't able to figure that one out.
Okay. Yeah, so it should have been 3. So then on the exam 2, it must have been a typo. So you guys will get credit for it. But it should have been a 3. There should have been a 3 there, not a 2 there.
Oh, okay.
Yeah. So, and then if it was this guy, then how would you name this guy?
So that would be is it
Is it aluminum,
Yeah, it's aluminum, selenium,
Oxide.
selenate. Oh, I'm not sure.
selenate, that's right, selenate.
Yeah.
Aluminum, now, would it be selenate or
Yeah, hyposelenate.
hyposelenite, right?
Right.
So it should be aluminum hyposelenite.
Okay, because it has two oxygens. Okay.
That's right. And 4 would be selenate. Selenite would be 3, and hyposelenite would be 2.
Okay.
So yeah, that subscript should have been a 3.
Okay, so that was question 38 on the exam.
Okay. So it'll be corrected. You
Okay.
guys will get credit for it if you had that question. So
All right, sounds good.
Okay.
That's all the questions that I have.
okay, sounds good.